Assalamu alaikum once again. Welcome back to my channel. Education is the key to success. This time you have known that what I'm going to do is I'm going to make an aeroplane, but it will be in three parts. First part will be covering, uh, I think so it is covering wing, and then second part will be horizontal tail and vertical tail both, and then going to fuselage, and maybe if I'm going to have fourth or the last part will be third part to assemble that in assembly. So what I want to show you is first I'm having some instructions. These are instructions. I'm going to import NACA-23012. You can have these points from your any website on Google. Open that your location where you install your Catia Dassault Systems B20, WinB64, and code and command. Here you can get that file of GD or GST like that. This is GST point supply or lot from Excel. This will be opening. Make sure when we're going to run, make sure that this is enable macros for running purpose as a program. You should have start loft, start curve, and then end curve, end loft, and end. Make sure that the left of the data is deleted, and at that side you should have the points of your NACA-23012 or any other file which you are going to import. And this is x-axis, this is y and z, and make sure that every x, y, and z axis point is in another column. Okay, but you do not need to do that. I am having file already, and if you need that from my site, you can just go into description. I've already made that file. You can see this file here open and made, and you can run it from view and macros. But before going to that, make sure I'm going to tell you that what it will be looking like. This is how this shape I'm going to draw in front of you. So just cross this, and before running your program, make sure that mechanical design part is in some file is open. Okay, so this is go to Excel sheet and macros and go to main and make sure that this is GST point supply lot from Excel. Okay, and then run this and make sure you need two. So two is the option for having points with sublines. Okay, this is going to be, so this has just ended. Now you can exit or whatever you want to do and minimize it. Okay, now you will see that I'm having this one fit all in. This is what I needed and I would have got same. Okay, now I want to open this in mechanical design in wireframe and surface design. Let me tell you, the leading point is this one, and this is point number 31. And what I'm going to do more is I'm first going to scale it because I need info for root code. N can be any number, but in meters, if I'm going to have n as 31, it should be in 31,000 millimeters because cat is spotting measurements in millimeters, and root code should be 0.5 of n. That half of n, 31,000 divided by 2 will be 15,500. So just go to here this option and scaling. You can find here insert and operations. Now operations wireframe, not services, issue divorce industry. uh, no, scaling option is not there. Here you can find in operations, you can find the operations, but I'm having here. So this is the scaling element is discipline, and reference is point 31, that is the leading point, and just I need it 15,500 mm. Okay, 15,500 mm. Have I got that? No, I think I'm not. So I'm just going to import it again. No, go to my Excel file, go to view, macros, and then again main, and okay, this is 2, enter. Okay, there was a why? Because I'm not mechanical design, part design. Okay, so then go there, macros, main, from Excel, run, option 2, enter. This is running. So this is my program is ended. This is fit all in what I need, and then go to mechanical design, wireframe and surface design. Now you can rotate it. I want to have scaling of this line with a reference of leading point number 31, and then this is of 15,500 mm. I'm not getting this. Why? I don't know. Issue is 15,500 mm. This is not getting that. Okay, let me clear that scaling. Delete. Okay. Again, having scaling element is this one. Reference point is point number 31, and this is 15,500 mm. I'm not getting this. I don't know. Let me try again. This is what we do if try in front of the audience. Yeah, if we tell you just what to do in the some part of recorded, just I show you the file, so that will be not going, you are not going to learn something from there. That is why I'm using. Once I got this is very easy. Great. This time it should do, inshallah. Going to the here, fit all in, setting a start, mechanical design, wireframe and surface design. Where's that? This is rotating it, scaling it, reference point 31. Now I got that, thanks Allah Almighty. Fit all in. Now you can just make sure nothing is selected more and just go and copy that sublime scaling, and in part body control V this. Now you can just hide this and go to part body and isolate this scaling. So now make sure, go first I was doing and I have got some error. Now I'm going to show you that error, that this is my second time I'm going to record this video because I got some errors. And what was the error? That I did not close this one. So just going to have line option. Line type is point to point, and this is what I've created. Now I will join this scaling one and curve one. This is just okay. So I'm not, this is my root chord, and what I told you that root chord should be 0.5 of n, and it's 31 meter, and Catia is working in millimeters, so that is 31,000. Half of that is 15,500 millimeters. Okay, just fit all in. Now I'm going to make the tip chord. Again I will be using scaling. So scaling element is this one. Reference is again that point 31 leading point. And what will be the ratio of, so that is root chord, and now we will define this scaling according to the root chord. So that is tip chord should be 0.75 of root chord, so scaling should be of 0.75, and this is what I've got. Now I want to draw the half span. Maybe the ZX plan will be suitable to draw that. Okay, draw some line having with some angle that is like that, and just make sure that this point, end point of line, and the point number 31 both are in coincidence with each other. Okay, now we're going to tell the length of the half span. So what will be the length of the half span? This should be going to and so half span of the wing should be 5 into root chord. Root chord was 15,500 multiplied by 5, that will be 77,500. Okay, so this is fit all in. Now I want to tell the sweep angle too. Select this was axis in this angle. So the sweep angle should be sweep of 0.25 into n. Do not use 31,000 here because it will be very large value. 31,000 multiplied by 0.25, that is, sorry, 31 multiplied by 0.25, that is 7.75. So this sweep should be of 7.75 degree. Okay, as it workbench have some big view. Now I want to rotate the tip chord to here, so I will use the translate tool. Element will be that this one, and direction, no, I want that it should be from point to point, and starting point is point 31, and no, I want here element is that, and starting point is point 31, and the end point is this point. I got that. So I am going to remove that scaling 3 hiding, and now I'm going to give some geometric twist to this, some geometric twist here, and for that again I'm going to ZX plane and sketch option, fit all in view, and just draw the line, vertical line this time, and vertical line will be, make sure that this point and this point are in coincidence with each other. Okay, exit the workbench. So I want to give it the geometric twist, and make sure that when I will move, I want to move this in some at some angle away from me, not towards me. Okay, that what should be the geometric twist? uh, geometric wing, and the geometric wing twist of 0.1, and that is 31 multiplied by 0.1 will be 3.1 degrees. So I want to rotate it. Element is already selected, I do not want to do that. So again, rotate option, and element should be this one, axis should be this one, angle should be 3.1. I want to make this preview that is moving towards me. I do not want that, so I will put the minus sign and just say okay. So I want to now hide that translate one and sketch 2. Okay, now I want to need what to do. I want to put some surface design that is here. I think so. Multi-section surfaces. This one and this one. Okay. And I want that I want to show you something. This is open. I want to close it. So insert surfaces, fill option. You can make sure that now I fill this. So this is half, and now I want to create the symmetry. Element is this one, and you're going XY plane. Okay, so this is your wing, what you need to or you want to create. And make sure that we have imported NACA-23012, and can be any number. I have chosen as 31 meter, and chord we are using this value root chord, and then we have used this value of tip chord, and we have used this sweep of 0.25 n, and then we have geometric wing twist of 0.25, and degrees and half span we have used it as 5 of a root chord. And now there's the next option of fuselage, and we will be having guide from here. So that was what I need and what I want to make. That is the part. So till now it is okay, and make sure you subscribe my channel, so when I will post the next video you should get the notification first. And for getting notification first, you should press the bell icon. So that is very amazing. So thanks for watching. May God bless you. Allah Hafiz.